Welcome to another exciting video on data cleaning using Python Pandas. I hope you're as excited as I am. In the first part of this video, we looked at how we can combine multiple PDF files and extract table data from it using the tabular library of Python. If you want to watch it, a link should appear somewhere on the screen right about now. For this part, we will first review the Excel file of data generated from part 1, go through the changes we need. Let me select all columns and change the width a bit so we can see the data. Control A to select all columns, then Alt HOI to auto adjust the column width. So far so good. I will also have my cell A2 selected and then press Alt WFF to apply freeze rows. Believe me, it makes it much easier to navigate and work through your data. Looking at the first column, the first thing we see is that there are two distinct dates, so we can see here. If I zoom this a bit, we can see two distinct dates which we can just separate from here. These need to be split into their own columns. Good thing is that they appear to be in a standard similar format, which means we can split them using length. If we scroll down a bit, we can see that the first column, some of the transaction description is appearing. You can see here. So this should technically go to column B, which is unnamed 0. So we need to extract and move this to second column. Good thing is these also seem to be in a standard length. So we can just split these on lengths. I'm also going to drop the last row. This row here, it does not have any description or transaction posting. Columns T and G appear to be empty, so these are also going to go away. We will drop them in such a way that our code always drops any columns or rows which are completely empty. Now that we have our list of data manipulations, let's jump to VS Code. We will go in reverse sequence of our corrections listed as it will be more efficient. First thing we will do is we will drop the columns and rows with no data. To figure out what rows are blank, we can use .isna combined with .sum. We can simply do is df cleaned .isna and we can do then .sum. Run this and this tells us what rows have how many blank rows. Transaction posting has 1 blank row. Transaction.1 has 0. Unnamed 3 has 33 blank rows. To add more context, let's print the shape along with this as well. To do that, we will need to wrap both lines in print statement, or else only the latest item will get printed. So for example, if I do this here, dot shape, then we can see we only get the last thing printed in the immediate window. So we need to wrap these both in print statement so we can get a print of both. And now you can see out of total 33 rows, 2 of our columns, unnamed 3 and unnamed 2, have 33 rows blank. It means it's fully a blank column. Let's write a for loop to drop rows where greater than 90% of data is missing in our rows. This will effectively drop 3 columns mentioned above. The columns that will drop will be this, and this. We can loop through all columns by using .columns property of our df. So for example, if we do this .columns, it will give us a list of all the columns that are available in this data frame. To loop through these columns, we can do a simple for loop. So we say for call in df underscore columns, which stores the list of all columns. We are going to write an if condition that checks for each column, which is stored in call variable, the number of empty rows by doing isna, and then doing a sum of those empty rows by using sum. As we have seen above, shape returns a tuple with rows and columns. We can grab the rows using square bracket 0 index. We do that and then multiply by 90%. So once this if statement is true, then we will just drop the column. For that, we will put the df equals to itself and then drop and columns is equal to call. Let's run this, add a shape at the end, and you can see now we have 5 columns compared to 8 columns before. So 3 of our columns have been dropped as planned. For our second transformation, we need to drop row with blank value in transaction posting column. We do this using .not na since we want to only keep non-blank values. Isna is the opposite of not na. So we have 2 methods here. You can either use isna or you can use .na. So what we are going to do is we will say df cleaned and then we select the transaction posting column and then we say not na. If we run this, you can see the boolean true false, and if we wrap this inside of the data frame, then you only get the rows that are not any. This is not changing the data frame in place, so you have to put it equal to itself and then you have the new data frame in place. Let's run this. Let's take a look at the shape, and now you see you have 32 rows instead of 33. So we dropped 1 row in the transaction posting column, which was isna, and we retained only rows which were not na. Now the third thing we need to do is we need to separate the description to its correct column. Before we proceed with this step, let's rename our columns. So we get our existing columns using column property, then convert it into a dictionary and pass on to a rename function. For that, we will say .columns, and now I'm just going to copy and paste this. and start converting it into a dictionary. Okay, so I've added a colon with each of these and an empty single quotes, then a comma, and so on and so forth. So we have the old name, colon, the new name, comma. So the way a dictionary works is we have the old value, we have the new value, this is separated by a colon, and then we give a comma, and then the old value, new value, so on and so forth. So this will be old value, this is the new value which are going to give. Now let's add in the new values. Okay, we are going to leave the last column as it is, which is PDF source. So now let's start building this. So we will say df underscore cleaned equal to itself dot rename columns, and then we put this equal to dictionary, and we provide the closing parentheses. We do a head method just to see if our rename worked, and you can see now we have nice looking column names. Now looking at our Excel file, we can see that we can easily split the descriptions after 2023 as the length is same for all of them. We are going to split here. Let's go back to our VS Code. Since we only need to fill in data for some rows, to do that, we will use lock accessor of Python pandas, which lets us work on selective rows instead of all rows. Before that, let's check what length appears how many times in trx underscore posting column. We do that by accessing length and then doing value counts on it. So to access length, we select the column, and then we do stir, which is for string. So if you are using any string methods, you have to apply .str on it. Then we do length, which is for length. And we have the length of trx underscore posting for each row. Now we can add a value counts in it to tell us how many values appear how many times. And you can see the length of 23 appears 21 times. Rest of the lengths are greater than 23. Let's quickly check what entries are for length 23. We do that by selecting this column, putting this equals to 23, and then we are going to wrap this inside of the whole data frame. And we get all rows where the length is equal to 23. And you can see all of these entries are the ones which have the correct description. Now let's quickly check what rows are written 23. So we just copy and paste this, and I'm just going to change this to greater than sign, run this. And you can see these are the ones that need fixing clearly in Excel format. Now I'm going to write a code for this and then explain what each portion does. Let me just copy and paste the code. So this portion right here is our filter. This is going to filter all of those rows which have length greater than 23. After the comma, this is our column name that we want the values to update in, which is description column. So we want the values to be updated in description column. After the equal sign, we are giving it the new value for those filtered rows. We can use slice or simple square bracket notation as well. Slice takes in the tuple as starting and ending values. Our starting point will be 24. For ending point, we will use a max of string length for trx posting column. So if I copy and paste this and run this separately, let's just see what this is. And you can see this is 64. So it's basically calculating the row for which has the maximum transaction posting length. So what this code is telling is for all the rows which have length greater than 23, in description column, fill the value from 24 onwards to 64. Which is the description. Let's run it. And let's check if our code worked by filtering and checking rows where length is greater than 23. And you can see for the same criteria, the description column was blank above, but now it has the description values from here till here. So you can see this has been split and extracted to its own description column. Now we can remove this extra description from 23 onwards and just keep the dates stored in here. We do that by overwriting this column and only retaining the length up to 23, which is from here to here. And for this case, it's from here to here, so on and so forth. So we put the column equals to itself, and then we tell it to only keep values up to 23's length, which is from here to here, and in this case here to here, so on and so forth. Everything before 2023, including 2023. This is being done by using indexing. Let's run this, and now let's check head and tail just to see if our method worked properly. And you can see we only have now date values within this column. We printed the top 10 rows by using head method, and then we printed bottom 10 rows using tail method. Moving on to fixing and separating the dates appearing in the same column. We use the same logic as before. Since our date values are at fixed position, we can hardcode the start and end position. We will use the insert method to add new columns. The reason for using insert is because we can control what index columns gets inserted at. Using the other method where simply you can put the name of the data frame and then the name of the new column, This works fine, but this always adds a column at the end of your data frame, which is not always desired, specifically in cases where you have a long list of columns. Insert takes in the first argument as what index columns need to be added to. Second is the name of the column, so you can name this anything. Third is the actual value that you want to fill in the column. So let me remove this and let me copy and paste the actual code and then explain. Now keep in mind that this happens in place, so you do not have to put this whole data frame equals to itself again. So 0th index means that this will be first column and 1 means this will be second column. We give the new column name, which is transaction date here and posting date here, and then we give it the value that needs to be filled in that column. So for TRX posting, we only want values up till 12th index, and for posting date, we want values from 12 to 23. So up to 12 is here till here, and from 12 to 23 is from here to here. Let's run it and see if we have the two new columns created at correct location. And sure enough, we have the first column here, second column here, and we have the correct dates here as well. Now interesting to see that the date format is appearing like this. That is because the dates are not yet in the correct format. Let's do a head and tail of TRX posting and our newly created two columns just to verify this quickly. So as you can see, these were the old values and these have now been extracted to their own columns. Nice, right? Tail method shows us last row is not a date and actually a subtotal. Let's get rid of this row. We can do this using contains with Boolean indexing and then using tilde sign to reverse our criteria. So we start writing our code. So let's select the posting date column and then we say .stir.contains, and we want to select all those rows that contain, let's say, sub t, and we need to add n equals false here. So this is going to select all rows that have sub t in there. So as you can see, you only have one true that is at the end. If we wrap this inside of the data frame itself, then we would only get the last value, which is true. Now this is good, but we actually need to reverse the criteria. We need to remove this line and select all those lines which don't have sub t in them. To do that, we just wrap this inside of a round bracket, add a tilde sign here. So this is going to effectively reverse this criteria. Let's run this and we should not be able to see sub t in there. And you can see we don't have sub t now. Fair enough. Let's now put this equal to itself. Since we know that our code is working, we run this and voila, we should not be able to see sub t row now. We can double check this by using tail method, and sure enough, we don't have that row here, which was here before, sub t as 36th row. It's not here anymore. Now let's convert these two columns to date and time. Now first let's check dtypes. So we do that by df_clean and we type dtypes. And you can see transaction date, posting date, these two are in object data type, which means that Python Pandas is not recognizing these as date time. You cannot use date time function on this right now. So let's convert these into date type. To do that, it's very simple. We select the column. So for first column is transaction date, put it equal to itself, and then wrap this inside of pd.to date time. pd.to date time. Now we do the same thing with the other column. So we use copy paste here, and then we do df.dtypes just to check that our columns have been converted successfully. And you can see we have datetime 64 and datetime 64. And now you can use datetime functions like .dt or month, etc. So for example, let's just quickly try it. So let's say posting date .dt.day, and this gives you the day of that specific date. Let's just do day name, and you can see you have the day name here as well. Keep in mind that unless your column is in proper datetime format, you cannot use these dt functions. All right, so far so good. Last thing we will do is to deal with nan values in location column. So let's look at available values in column using value counts. The column we want to look at is the location column. So let's say we do isna and we wrap it inside of the whole data frame. You can see we have these rows which have the location as nan. We can achieve the same thing by using value counts. Let me add this column again as to value_counts. So we don't want it to drop any blank rows, so we add drop n equals false in there. We have 15 nan values and our max value is Islamabad, which appears 6 times. Then we have 3, 2, so on and so forth. Now let's modify our value counts method so it's able to calculate max value dynamically, excluding the nans. So we simply copy and paste this line here. We remove this from here because we want it to automatically drop the nan values, and the top value is Islamabad. We need to figure out a way to extract this value so we can use it to fill na values. So we use idxmax What this is going to do is this is going to extract the highest value, which we can now use elsewhere. So let's use fillna. So we select our column, which is df underscore location dot fillna. Now we give it the value that we want to fill it with. The value we want to fill it with is going to be stored in this. The benefit of this is it's always going to be dynamic. So if your data set changes and some other value is the max value, then this is going to use that value. Now keep in mind that you need to put this column equals to itself, or it's not going to make any changes. The other way you can do is you can use in place parameter, which is not recommended. So let's run this, and let's also do value counts with drop n equals false. And you can see now Islamabad has 21 rows. Now we need 3, and there are no nans. So as you can see here, all the nan values, 15 values were filled with Islamabad PK. So we have 15 plus 6 equals 21 values. Now that we have done all the data manipulations, let's export our file to Excel and take a quick look side by side of clean data versus bad data. Let's export the Excel file. And you can see we were able to split the description to its own column. So you can see description sits in own column. We were also able to extract the dates into their own 2 new columns, as you can see, transaction date and posting date. And we filled the empty values or nan values in location column with the maximum occurring value, which was Islamabad, as you can see here. We also renamed the columns to make it look a bit nice. Right, so this wraps up the video on data cleaning. I hope you enjoyed watching as much as I enjoyed doing these data manipulations. Till next time, happy learning. If you like the content, consider liking and subscribing, and I'll see you next time.